Welcome to Lesson 12, Simple Queue Service. Introduced to production in 2006, SQS is a distributed message queuing service. It is a managed service that you can interact with programmatically to store messages for later processing. In this lesson, we'll review SQS queues, how to create and use them, and how to interact with them from AWS Lambda, which is a serverless code execution environment. Amazon SQS is a managed queue service offered by Amazon for storing messages, retrieving them, processing them, and deleting them, just as you would expect any managed queue to do. So we break down the name. It's pretty simple. It's a queue. It's a bunch of items that need to be processed, and it is an AWS service. We have some salient features listed here. These features are listed by Amazon, so the messages can be secure, so you can do some server-side encryption there. Messages are durable. They are replicated across multiple servers, reliable, again, falling into that replication amongst multiple servers bucket. Scalable. You can ingest many millions of messages into your queue with SQS. It is, I won't call it infinitely scalable, but you can put a lot of data into it very quickly from distributed sources across the globe. And actually, the demo that we do is replicating a voting application. So along the lines of a TV show that has people singing well, that may request votes from their viewers. The demo has, it's along those same lines where we ingest votes and then store those votes into a database. There's two different types of queues available, standard and FIFO, and we will look at both of those here in just a moment. Accessing SQS is through the normal methods. You have the web console to access SQS, and you can create messages and put them into queues from the management console itself. We'll take a look at that. You can use the CLI for creating queues and adding data into queues, retrieving messages from queues, as well as deleting messages from those queues. AWS tools for PowerShell, as well as the AWS SDKs, can be used to interact with SQS. Also, all of these use underneath the covers the SQS Query API available from Amazon, which you can interact with directly if you choose to. This picture I'm showing here, I got this from the Amazon documentation for SQS. It shows a simple use case. Users are talking to a web server, sending some data there. That goes into a queue. Some backend processing servers will retrieve a message from the queue, process it, and then delete it. Send the response back to a response queue, which goes back to the web server. So the web server is both producing messages as well as consuming messages to two different queues there. SQS queues are simply a temporary repository for these messages that are awaiting processing. It allows you to decouple distributed systems. So as our picture is showing here, we have web server serving clients, and we have a processing server or a group of processing server that is handling the processing that needs to occur. And we are distributing that functionality using a common broker in the middle, that being AWS SQS. It does offer dead letter queues, and I'll explain what a dead letter queue is here in just a moment, and cost allocation tags. We'll talk about those as well. Two different queue types, standard and FIFO. Starting with standard, this is the normal one that you will most likely be using. Available in all regions, unlimited throughput. Now, Amazon says nearly unlimited, quote unquote, with respect to the number of transactions per second. This is going back to my voting example. If you had 15 million votes that needed to be ingested within a few seconds, you could do it with Amazon SQS. At least once delivery. We're going to dig into this at least once here in a following slide, but it basically boils down to a message is guaranteed to be delivered at least one time. And standard queues follow this best effort ordering model. You could receive messages out of order. If you take a look at the picture at the bottom, again, these pictures came from Amazon. The standard queue is showing 1, 2, 5, 3, 3, 4. So you notice that number 3 was received twice. That falls into that at least once delivery bullet, which we'll talk about here in a minute. For FIFO queues, they have high throughput, but it is not unlimited. We see here 3,000 messages per second if you are using batching, and 300 messages per second if you are not batching. And batching is simply putting multiple messages into one call to the queue. Exactly once processing is available with FIFO queues. So message number 1 in our picture there is going to be added to the queue, and then it will be delivered exactly one time. And that message needs to be processed and deleted for number 2 to be pulled from the queue. This is first in, first out. The order is maintained and preserved through the queue. So at least once delivery, what does that mean? When a message is received by SQS, it's copied to multiple servers. That is our redundancy and our fault tolerance and durability of our messages being distributed across multiple servers, so that whenever we receive it, we can ensure that we have actually what was added to the queue. A server, so at least once delivery, these next 3 bullets apply to this. A server with a copy of the message may be unavailable when the message is received. Received here doesn't mean received into the queue. It means pulled from the queue. And in the event that that request is made and then another request is made, it's possible for that message to be sent out twice, but it's guaranteed to be sent at least once. Now, I shouldn't use the word sent here. It's retrieved. So a consumer of this data needs to go to SQS and say, hey, give me a message. It'll pull it down, process it, delete it, and then the next message will be pulled out. It is your responsibility as the developer to handle the duplication of data that occurs when more than once delivery occurs. It's your responsibility to handle that gracefully. Amazon cannot account for that unless it's a FIFO queue. Visibility timeout. This is a key concept with respect to queues. So the timeout, visibility timeout, is the amount of time a message in the queue will be hidden from other consumers while it's being processed. So let's take an example of a 30-second visibility timeout. I have this nice chart here on the bottom. Again, this chart came from Amazon. This is a time chart, so time is moving forward towards the right-hand side of your screen. So the message is received. That means that a consumer has retrieved a message. At that point, that's T0 or time 0, the visibility timeout starts. While that visibility timeout has occurred, if another consumer requests a message, it's not going to see this message as being available. As far as SQS is concerned, this message is being processed by a consumer, and we should not hand it out to anybody else. Once that visibility timeout expires, then that message will reappear in the queue and it can be consumed. So the flow here is a consumer receives a message, it processes it, and then it sends the delete message command over to SQS. Once that delete occurs, then the message is gone and it's not going to be consumed by somebody else. The visibility timeout exists so that if a consumer fails to process a message, another consumer can go grab it and process it. And it also can be helpful for the dead letter queue. So you can move items that sit in here for too long into this dead letter queue so you can debug. And we'll take a closer look at that here in just a moment. Here's some defaults for visibility timeout. It defaults to 30 seconds. You can change that to 12 hours if you need to. A message that is in its visibility timeout period is considered in flight. So there are limits to the maximum number of messages that can be considered in flight. If you were to add, say, 200,000 messages to an SQS queue, and then you go and try to consume all of those at once, it's going to stop you at 120,000 for a standard queue and 20,000 for a FIFO queue. Let's say you don't overload SQS. It's Amazon protecting themselves. There is a message retention period as well. This is the maximum amount of time that SQS will hold on to a message and wait for it to be processed by a consumer. The default is 4 days, and you can modify that to 1 minute as a minimum or 14 days as a maximum. So you can only allow SQS to hold on to a message for 1 minute if you chose to, or you can have it sit there for 14 days, and then every 14 days start up your consumers, consume everything in the queue, shut them down, and then just wait. And the queue will continue to retain those messages until that 14-day timer expires. Message size limits. The maximum is 256 kilobytes, and that is the default. The minimum size limit is 1K. So this would say, if you were to set it to 1K, that means it will not receive or allow you to put a message into the queue that is more than 1 kilobyte. There is also a feature for delaying delivery, or rather delaying the consumption of a message from the queue. This is, as you add a message to the queue, you can change the delivery delay to be up to 15 minutes. That means that the message will sit there invisible for that amount of time. You can do this in 2 ways. One is on the queue, and when you add a message to the queue, you can set a delivery delay there as well. If it's set to 0, then it can be consumed immediately. You can send messages from within the web console. I have a screenshot of that here. You simply enter the message body, and you can check a delivery delay for that individual message whenever you add it. Once you add the text here, you can set attributes. We'll look at attributes in the demo. And you add the message body, hit send, and off it goes into the queue, and it's ready to be consumed at that point. This delivery delay is not supported on FIFO queues. FIFO queues have to be first in, first out. It is very strict about that, so you cannot delay delivery in a FIFO queue. The dead letter queue is for messages that fail to be processed. So if a message has been consumed X number of times, and that X exceeds the maximum receive count setting of the queue, then it gets moved into a dead letter queue, provided you have configured it. This is called a redrive policy. So when you're in SQS, when you configure a redrive policy, you are saying that if a message is consumed this many times and it hasn't been processed successfully, I want you to move it into this dead letter queue. The queue maximum receive count has to be between 1 and 1,000. Cost allocation tag. So I mentioned there's 2 useful features for SQS, one being the dead letter queue. This is the other one. You can add key value metadata to a particular queue, and this information can be seen in billing. So you can bill particular departments based on which queues they're using. I have some examples here. I have a QA queue, or a quality assurance queue, and a production queue, and then maybe the testing group has to pay for this one, and the production group has to pay for the other one. Server-side encryption is available to you. So as messages are added to the queue, SQS can encrypt those as it's holding on to them. This does allow the transmission of sensitive data, and this is all managed through the Amazon Key Management Service, or KMS. There is certain pieces of the message that get encrypted and some pieces that are not. The actual body of that message is encrypted. What is not encrypted is the queue metadata as well as the message metadata. So in that previous screenshot where I had attributes on that tab that I wasn't showing, those particular attributes are not encrypted. If you move a message from the actual queue into its dead letter queue through the redrive policy, it will still be encrypted. And I have this note here that SQS in China does not allow server-side encryption of the data in a message sitting in a queue. Authentication to both the SQS interface on the web console as well as adding data into and retrieving messages from a queue is provided by IAM. There is also, similar to DynamoDB, there is an access control setting that is per queue that allows you to specify permissions. The language is also JSON, similar to IAM, and we'll take a look at that in the demo. CloudWatch monitoring is available for queues, so as messages go into a queue and are received from the queue, different metrics get pushed out to CloudWatch every 5 minutes, and you can see for both standard and FIFO queues what the metrics are looking like over time within CloudWatch. These are the metrics that they give you in CloudWatch. So you have age of oldest message, number of messages that are in that visibility timeout period, how many are visible, how many have been deleted, etc. So you can see all these different metrics within CloudWatch. SQS queues are pretty easy to create. We can do it through one of 3 different methods, either through the web console, or through the AWS CLI, or through the SDK. And we're going to look at all 3 of those here in this lesson and the next lesson. Let's go ahead and jump in. This is queue creation, and we're going to look at creating a queue through both the web console as well as the AWS CLI. Starting here with the web console, we'll go to the SQS service. You can see I have no queues created, so it shows me an informational screen. And click on Get Started, and it asks me if I want to create a queue. So let's call this TQ1. Two options for queue types. We have standard and FIFO. These pictures are extremely helpful because they give a nice, concise explanation of what the queues look like as far as ingestion and digestion. I guess that would be the right word. With standard queues, it's not guaranteed to be in order. It says here best effort ordering. And then FIFO queues will always be first in, first out. All right, so we have, once we give it a queue name and we select the queue type, we can do quick create, and that will set defaults, or we can configure, which will show the configuration options. These are the default parameters. Default visibility timeout's 30 seconds. So this means that it's going to hide a message after it's been received for 30 seconds. If it's not deleted in those 30 seconds, it's going to be available for someone else to receive it. Message retention period is the amount of time it's going to hold on to a message that hasn't been deleted. Maximum size between 1 and 256K. The amount of time for the delivery delay that we want to hide a message before it is available to be received. That can be up to 15 minutes. Receive message wait time. So the maximum amount of time that long polling receive call will wait. The SDK takes care of that for you, as well as the CLI, meaning that it will poll and then an empty message will be received. 0 is infinite. All right, next up, redrive policy. So if we want to move a message after it expires from the standard queue or a FIFO queue into a dead letter queue, we check this box, we give it a queue name, and then the maximum number of receives before it gets moved into the dead letter queue. I think just a moment ago I said timeout, and I meant receive. So the maximum number of times it can be received before it gets moved into this dead letter queue. We have server-side encryption, and we can specify a key for that encryption through the Amazon Key Management Service. And I need to uncheck this box if I want to actually get the create button to show up so we can create that queue. So very simple. That's the creation of a standard queue. Let's create a FIFO queue. We'll call this TQ2. And if I click FIFO queue and then configure queue, I'm going to get an error. Where'd the error go? Didn't show me there. Anyway, FIFO queues need to be named .FIFO, .FIFO. You see the blue box is hidden from me. Let's go ahead and change that to .FIFO. See, there's the error. So it only shows up as you're typing. That's unfortunate. Anyway, the FIFO queues need to be called .FIFO. Now our blue button exists. All the same default parameters are set, and we can create that queue. So now we have two queues created. We can see all the permissions down here, the dead letter queue, monitoring, tags, encryption, Lambda triggers. You can as well put data into a queue. So I'm going to select TQ1 here, and I want to send a message to this queue. We will say hello world. We can set a delay per message, or you can set it on the entire queue. Let's go ahead and send that message and close it. We can see there's one message available. Now, if I view delete messages, it gives you this informational warning here that whenever you poll for a message using the web console, you are actually removing it from that queue. So keep that in mind. It's going to go into that visibility timeout period once you pull a message down. So here's our hello world message. If I were to pull this queue right now from something like the CLI, that message would not show up because of that visibility timeout. Let's go ahead and delete that one message, and off it goes. So now we have 0 messages available. All right, now we're going to take a look at doing the same thing, but in the CLI, the command line interface. All right, let's jump over to our CLI. If we look at AWS SQS help, we have a whole bunch of options down here. Permissions, create queue, add messages, delete messages, list queues, send batch of messages, whole bunch of fun stuff. Let's go ahead and create an actual queue. AWS SQS create queue --q UE name is going to be test q1. And there's our queue URL. Whenever you put messages into a queue, then you're going to need that URL there. If we jump back to the console, refresh, there's our test queue. That's the one I just created. And we can specify, let's go back into the help here. Doesn't show it in the the command here. Should be on the web page though. Anyway, there is the command AWS SQS create-q. Give it a name. And you can specify the attributes on the command line. This is expecting JSON format for the attributes. Let's go ahead and set the visibility timeout to 120. All right, there's our new queue. Let's go ahead and refresh this. Test Q2. And here's our new visibility timeout. So 120 seconds is 2 minutes. So all of the things that you change whenever you're creating a new queue, all of the settings that are available to you, when you configure a queue, you can specify in attributes. And the you see these two links right here, the developer guide and facts, can get you information about those particular attributes. All right, so that is very generally creating a queue. And I went ahead and touched on interacting with queues, which is actually the next sub-lesson. And let's go ahead and jump into that now. In the previous lesson, we learned how to create a queue, both through the CLI and the web console. We also looked at interacting with a queue through the web console. In this sub-lesson, queue interaction, we're going to look at interacting with the queue through both the CLI as well as the SDK using Node. Starting out with the CLI, let's go ahead and jump into SQS here. See that we still have our queues created. I'm going to be interacting with TQ1 here for no particular reason. Let's get over to our CLI and we will AWS SQS list-queues. So we have 4 different queues created. I need this URL in order to interact with the queue from the CLI. Let me go to my notepad just to make things a little bit quicker, and we will replace the URL with the actual URL. Just a moment. I want to make this a little bit bigger for you so we can talk through these commands. And I'll turn on word wrap. Okay, so here's my list queues commands. I already did that. Next up is send a message. We give it the URL, and it looks like I messed up there. AWS SQS send message queue URL. There's the actual URL to TQ1, and then the body of the message is JSON. We have an ID, and we have the actual message itself. Let's go ahead and send this message. Come back over to the CLI and paste that in. It gives us a MD5 hash of the body of the message as well as the ID of the message. If we go take a look at TQ1 and let's view delete messages here. Start polling. There's our message. More details. So we have our message body. There's the full JSON of what I sent in. And then we have attributes. If we wanted to, you can put attributes on a message if you so choose. Here's the other information, the ID, that MD5 sum, the size of it, sender account ID, the time it was sent, when it was first received. So this first received date right here is actually because of the web console doing this long polling for messages here. Let's go ahead and close that now. Let's actually receive a message from the CLI here. Receive dash message, and then you need the queue URL, which is this TQ1 URL here. All right, so I just received a message and the visibility timeout has just started. If I try to receive another message, there are no messages available. If I sleep 30, which is the default timeout, then after 30 seconds, when this command executes, I should re-receive or be able to pull this message again, this body of test message. So let's give this the 20 more seconds or so to see that happen. So there it is. That same message, I was able to receive it again. And if I go try to grab it one more time, it is not there because of that visibility timeout. So that is interacting with a queue through the command line interface. Now we're going to do the same thing with Node. All right, so there's a whole bunch of files in here. We have config.json, consumer, create queue, and producer. Those are the important pieces. And let's take a look at some of these files here. So config is going to have our node configuration for AWS. That's our access key, secret key, and the region. Settings has some settings that the various scripts, whether it's consumer or producer, reference. Now, what this application does is it simulates a voting application. So imagine a scenario where you had, say, an online TV show that was people singing, and you vote by phone. And when a person sends a text message, the receiver of that text message, meaning the other end, the server side of it, the processor, could take that data and shove it into SQS, and then some consumers inside can pull those messages and increment vote counts as the votes are coming in. So you can separate the production of messages from the consumption of messages and allow them to sit there so there's no dependency on one or the other. So the first thing I need to do here is run create queue. Let's see what that does first though. So we have our AWS and file system. We load our config for AWS from config.json. We get the settings from this file, settings.json. We create an SQS object, and then we create a queue. This is createqueue.js. That's its one job. Its job is to create a queue. The queue that it's going to create is specified in that settings file, settings.queuename. I don't remember what it was, so we'll take a look at that here in a moment. And then it runs simply the function create queue with the parameters specified, these parameters being queue name. Let's go ahead and see what that was. So our queue name is AWS dev queue. So let's go ahead and execute that. I need to install as well. I need to modify this information, the access key and secret access key. So let me go ahead and do that. I'm going to cat tilde.aws credentials, and I will grab this information and edit config.json. Temporarily drop that guy in, and let's see, your, and then the access key, and then region, we'll put it in US East 2. So we have our packages installed, and now I should be able to run create queue. So I just created AWS dev queue. Jumping back over to our console over here, we should see that queue now created. AWS dev queue. And now we have two more applications in here. We have producer and we have consumer. I'm going to go ahead and open up another window. And let's put it top and bottom. And up top, actually on the bottom, let me get to where I need to be. So top is going to be producer and bottom will be consumer. And what producer is going to do, let's take a look at it. Its job is to cast votes. So it's going to randomly pick a winner, or rather a vote, and it's going to send that into the queue. It gives us some information. There is a setting in that settings file for the total number of votes we want it to cast. It's going to create the message and then send it off. As far as consumer, what consumer is going to do. So let's see what we got here. We create our SQS. It does create a local SQLite database, which is where it's going to store these votes. We get the queue URL, pull for messages, receive a message, take the information from the message, increment the votes. So we see here insert or replace into votes, and then it will delete the message and it will just keep running, consuming votes as they come in. So let's go ahead and we'll start consumer. So it's running, it's waiting for votes. Now let's run producer. So it cast 10 votes, and we can see our consumer down there. It's grabbing those messages, and let's wait for that to finish. It's going to grab 10. All right, it's done. So it's got 10. Let me go ahead and kill the consumer. Actually, I had that interrupt catcher right there, so it tells me the total vote tally whenever I killed it. We got three-way tie for first place: Sally, Alice, and Jim. So it received a vote for Sally, updated the database, deleted it. and then it went on to the next one and just kept polling for messages. So you can see how consumers could be scaled horizontally to, you know, as the need increases. And then SQS is, as they say, infinitely scalable. It can receive a whole bunch of votes, and then you just scale up your consumers in order to be able to process all the votes. Let's make this a little bit bigger. Let's do, let's modify our settings, and let's cast 1,000 votes, and we're going to poll at 10 milliseconds. I haven't tested this, so let's see what happens. And it is moving. We'll kill that when it's done. It should be relatively quick. Well, actually, if we did the math. All right, let's go ahead and kill that. All right, what do we got here? It looks like Jim is currently in the lead with 282 votes, followed by Alice, John, and then Sally. And the actual database is still here. I don't know if I have SQLite installed, but let's see. I do. So there's our actual votes right there. So that's an example of interacting with a queue from the SDK. In this case, we're using the Node SDK. Same functionality is there for Python, for Java, Go, whatever language you're using. There's most likely an SDK for it. So go play with this stuff. It is a lot of fun. The final thing we'll be looking at in the SQS lesson is the consumption of a message by Lambda. So as a message gets sent into an SQS queue, you can configure a trigger that will send that message over to a Lambda function for processing. That Lambda function can do whatever you want because you can specify the code in the Lambda function that executes and processes that message. In this example, I'm going to create a queue. I'm going to send some messages into that queue. The messages that are going into that queue are going to be processed. It's going to trigger a Lambda function. They'll be processed by Lambda, and we'll take a look at the logs that are generated as the messages go into Lambda. Now, this is not the Lambda lesson, so I'm not going to touch on everything I'm doing in Lambda, but I will walk through the steps to create that function. So we'll head into SQS, get started now. Let's create a queue called Lambda invoke. Standard queue, all the defaults are good. Quick create it. There is our queue. If we take a look at, let's get rid of that guy right there. All right, just to start with a clean slate. All right, we have Lambda invoke. There are no Lambda triggers currently configured on this queue. So I'm going to have Lambda create the trigger for me. Let's head over into Lambda. And I need to create a function. And there is a blueprint for SQS. So let's go ahead and search for SQS. There's an SQS poller. We will call this SQS ingestion. I need a role. Create a new role. We will call this role SQS ingestion role. This is for permissions to interact with SQS. Policy templates, SQS polar permissions, which are just fine. I am going to need to modify the policy that it creates, but we'll do that in just a minute. The queue, it's not showing me my actual queue. Let's come back to functions, create a function, blueprints, SQS, search, polar, configure. Let's see if it's showing. There's our queue. All right, had to wait a moment. All right, SQS ingestion is the name of our function. We're going to create a new role. We will call it SQS ingestion role. Policy template, SQS polar permissions. I will need to modify that. Batch size is 1. So you can have this function pull in more than one message when it goes and grabs them. When I click this button, it's going to configure the queue and add the trigger. Here is our function down here. Let's go ahead and create. All right, it looks like it gave us an error. That's all right, we'll fix it here in a minute. All right, we need an SQS trigger. That's done. Let's configure that guy. We got Lambda invoke, batch size 1. Add that. That's good. Here's our actual function. Let's go ahead and uncomment this one line so we can get a little bit more information. And Before I save that, I want to modify our IAM role. Let's look at the role that it created. SQS ingestion role. We see these two policies. These are customer managed policies. So we have, this is for creation of log groups from Lambda. And then this one will allow us to receive messages and delete messages. All right, I'm not going to modify this. I want to see, just based on looking at these policies, I think it's going to work. But when I was writing my demo guide, my notes for this thing, I did have an issue and I had to modify it. So let's leave it. We'll see what happens. Now let's hit save on this. We have our two saved, so that's all good. So there's our function. Let's look back at our queue. We'll refresh this. Here is our trigger. It says creating, so we got to give it a few seconds. Okay, our trigger is enabled. So now if I put a message into this queue, it should execute the Lambda function. So let's send a message. This is a test message. Send. Done with that. Let's head over to our monitoring for our function. View logs in CloudWatch. And we can see we're in the log group Lambda SQS ingestion. We'll refresh it. Received event. And we have an array of records that were received. There was only one record received, and that is it right there. This is a test message. So from within our function over here, we could actually process this information. So we have the event.records for each, then which is an array. Records is an array, and contains both message ID and body, and you can do something with that. So you could take this information and say, for example, put it into DynamoDB. If it was that voting application, then you could increment the counter for a particular contestant from within this Lambda function, and then Lambda can auto scale for you. So you don't have to worry about manually scaling your consumers of these messages coming out of the queue. Lambda can do it for you. So that is triggers on SQS queues. And those triggers are calling Lambda functions to process the information in the message. So SQS is a pretty simple service. It does one job and does it well. But we do have some recommendations for best practices for SQS. Your visibility timeout, you want to ensure that you allow sufficient time for your consumer to actually process that message and delete it. So we recommend process time plus delete time plus a buffer, however long that takes, however many number of seconds, then tune your visibility timeout based on that. In the event you encounter an error, then use exponential backoff to retry those requests. Don't just keep hammering at the API in order to get data. Use long polling where possible to reduce SQS fees. Now the SDKs do this for you automatically, but if you are interacting with it, say through the API directly, then use long pollings. Make the request and wait for some data rather than request, disconnect, request, disconnect. Use a redrive policy to capture messages that fail processing. This is our dead letter queue. So as items fail to get processed in sufficient time from some sort of source queue, stick it in a dead letter queue, and then finally have it removed. Keep this point in mind. Message in queue time does not change whenever it moves to that dead letter queue. So if the message is received on June 1st, then when it moves to the dead letter queue, it was still received on June 1st, and it could be deleted at the maximum lifetime for that particular message. So keep that in mind. Make sure that the lifetime is sufficient to account for how long it might have sat in the actual source queue. And avoid setting the number of maximum receives to 1 in the dead letter queue, because if it goes into the dead letter queue, that means something happened to where it wasn't successfully processed from that main source queue. So whenever you start up your application, in order to investigate that, you don't want the maximum receives to be hit very quickly, because then you'll lose the message. You won't be able to investigate why that happened.